Welcome to Brain Vision.
Let's use the chain rule to find dw over dt. And we'll start off with a tree diagram here. From this first equation, you see that w depends on x, y, and z. And then from these three equations over here, you see that x, y, and z all depend on just one variable, t. So now we'll go ahead and use the chain rule to write out dw over dt. So how do you go from w to t? Over here in the tree diagram, you can go from wx and then x to t. You can also go from wy and then y to t. And finally, you can go from wz and then z to t. So we'll have to compute each of these partial derivatives. So for the first one here, so we'll have to differentiate this ln of the radical. So when we do that, we'll have 1 over the radical. And then we'll have to take the derivative of inside the ln. So that'll just be the 1 over 2 times the radical. So that's all in the denominator on the bottom. And then times the derivative of inside the radical, which is 2x. So cancel out those 2's, and you get x over x squared plus y squared plus z squared. After you go ahead and multiply these two radicals together, you could just go ahead and drop the radical. And again, we canceled the 2's there. So that'll be the first term. And dx over dt, derivative of that is just cosine t. Now, we can avoid some work here because the derivative of w with respect to y or z will be very similar to the derivative of w with respect to x, except now we'll just have to switch the numerator. So this time we'll get a y in the numerator. Then derivative of cosine. Similarly over here, this time we'll get a z in the numerator. So here, I'm running out of room here. Let me go back and erase. And then now we have the derivative of tangent giving us secant squared. And perhaps here, I guess in this case, they all have the same denominator, so maybe we can just clean this up a little bit. And then all over, we have x squared, y squared, and z squared, and that's our final answer.